In this video, we'll be solving this geometry problem relating to sectors of a circle, formulas, and central angles. Now here is the problem statement, and here is our blank circle, which we're going to diagram and fill out as we work on the problem. So the problem statement says, a sector of a circle has a central angle of 80 degrees. If the area of the circle is 32 pi, then what is the radius of the circle? Now, before we get started, let's define exactly what a sector is, in case you are not familiar with the term. So a sector of a circle is, let me go ahead and create the center point, we'll call it O here, of this sample circle. A sector would be a portion or a chunk of a circle formed by 2 points on the circumference of the circle. So for this particular problem, I'm going to draw a line here, and we'll call this point A here. That's the point where this line from O meets the circumference of the circle. So line OA there. Then our second, this is the other end of the sector. It's going to be over here. Of course, this is not to scale, clearly. We're going to call this B. So this whole thing, the shaded area, the area inside this thing, OAB, that is the sector. So we just refer to it as sector OAB, or the central angle being AOB, if you will. So we know this here, the central angle is 80 degrees. That's what they mean by the central angle. It's the angle in the center of the sector. So yeah, the whole thing, that chunk over there that looks like it's somewhere around a quarter of a circle, or maybe a bit less, that's the sector. That's what it means. Okay, so we know the area of the circle is 32 pi. Okay, and so, this is pretty basic here, but since the area of a circle formula is going to be pi r squared, we know right away that our r must be 6, because 6 squared is 30, not 6, but it would just be a generic 30 square root of 32. Now, that's what we're trying to figure out, because we need to figure out the radius of the circle. So here's our formula, and we need to plug this into a larger equation that takes advantage of the rules about the sector of a circle. So we know the area is pi r squared, and we know that pi r squared, I could add on to this, is equal to 32 pi, because that's what they tell the area to be. So there is a formula for calculating the area of a sector of a circle, and we can use that information to figure out, based on the area of the entire circle, what the radius is. Now keep in mind that the radius of the circle is the distance from the center of the circle, which in this case is O, to the edge of it, basically, the circumference all around it. So like point B, for example, OB here, the line from O to B would be the radius. So that's a side here of our sector. Okay, so let's go ahead and write out the formula. We're going to explain what the different x's and r's mean in a moment. So our formula here is going to be starting off with pi r squared times x over 360. X over 360 is equal to our 32 pi, because that's what they said the area was. So here, the r, of course, is equal to the radius of the circle, which we're trying to figure out. That's going to be the variable we're solving for. And our x is equal to the central angle, which in this case is 80 degrees. So all we need to do from here is solve this equation. It's pretty simple. All we have is the pi r squared times x over 360, and that gives us the total area. And all we need to know from there is r. So we're just going to do some pretty basic algebra here. We're first going to substitute in the value of x, so that's 80, over 360 equals 32 pi. Okay, then we can simplify this fraction. We can first chop off the zeros here, which leaves us with 8 over 36. Then we divide by 2 on top and bottom. You got 4 over 18. Do that again, and you get 2 over 9. So 2 over 9 is our simplest form fraction here, which is equal to 32 pi, once again. Okay, so let's go ahead and see if we can solve this equation for r right here. We need to make sure we see. Okay, so 32 pi here. All this is telling us we can combine this into a single fraction if it's any clearer. 2 pi r squared over 9 equals 32 pi. Okay, and since 32 times 9 is going to be 298, that tells us that the numerator, this upper part of the fraction here, must be equal to 298, because 298 over 9 is going to be 32. The left side is going to have a pi multiplied by it, and so does the right. So that would make it equal. Now all we have to do is find out the value of r that makes the numerator equal to 298 pi. So we have 2 over here. We divide 298 by 2, cut this out. That gives us 144. Oh, nice. 144 is actually a perfect square as it happens. And the square root of 144 happens to be 12. So that tells us right there that r must be 12. We can check this by saying if r is 12, then we have 12 square root is 144. We can plug this in, look at our original equation. 144 times 2 is 288. That results in 288 pi on top, or 298, sorry. 298 pi on top. Oh no, it is 288. Okay, 288 pi over 9 equal to 32 pi. Okay, and indeed, 288 pi over 9 would give you 32 because you simplify the numerical parts of this fraction. So, and that's how you would get to your final value of r. r equals 12. Let's write this out here. And that r right there represents the radius of your circle, which is what they asked for. So in summary, to solve this geometry problem involving sectors of a circle, we had to use the formula primarily for the area of a circle. We then multiplied that by x over 360, since the sum of the total angle in a circle is going to be 360 degrees. Then we used some algebra to solve for the value of r there, given that our x is 80 degrees, or the central angle in the circle.